Hello everyone, my name is Sarah and this is a general overview of the digestive system. So we are going to cover the entirety of the digestive system from the mouth to the anus, and we're going to cover the function of all the organs as well as some of the physiological processes. So let's go ahead and let's get started. Digestion always begins with the mouth, where two processes are taking place. One is mechanical digestion. Through the grinding of teeth and chewing of food, you are creating what's called a bolus. There's also chemical digestion via salivary amylase, which is just an enzyme that converts starch into sugar. And so just note that the mouth is where carbohydrate digestion begins. And so the bolus that you've just created is going to go from the mouth to the pharynx and through the esophagus. Now, the pharynx is the part of the throat that's anterior to the esophagus. It has a role in both digestion and respiration, so when you're swallowing, food is passing through the pharynx. It is divided into three sections. There's the nasopharynx, which is posterior to the nasal cavity, the oropharynx, that's the soft palate or the roof of the mouth, and we're concerned with the laryngopharynx, which connects to the esophagus. Now, let's just quickly touch on the larynx. The larynx is the voice box, so this is where sound is produced. The larynx is also associated with the epiglottis. Now, you guys are all familiar with the epiglottis. The epiglottis basically protects the trachea. It's just a flap that sits on top that opens and closes. So when you're drinking, say, liquid, the epiglottis is supposed to close. And if it doesn't close in time and some liquid makes it into the trachea, you start coughing and then you say, oh, it went through the wrong pipe. So when you say it went through the wrong pipe, that's because the epiglottis didn't do its job. Alright, so the bolus has now passed through the pharynx into the esophagus. The esophagus just connects the pharynx to the stomach. Food, or the bolus, moves through the esophagus via peristalsis, which is just rhythmic muscle contractions. Food is then, or the bolus, is going to move through the esophageal sphincter at the very end of the esophagus into the stomach. Alright, so at the stomach, food is entering through the esophageal, or sometimes called the cardiac sphincter. When food is ready to leave the stomach, it passes through the pyloric sphincter into the small intestine. Now, inside the stomach is what's called gastric juice, and this gastric juice contains hydrochloric acid and pepsin, which both aid in digestion. Pepsin, in particular, digests proteins, so the stomach is where protein digestion begins. There's also rugae, which are the internal surface of the stomach that allows for stomach expansion. And once in the stomach, just note, the bolus becomes chyme. Alright, so we've made it to the small intestine, and this is where absorption and secretion and just all-around chemical digestion takes place. There are villi and microvilli, which increase surface area for digestion, and also the reason why the small intestine is so long is to increase the amount of time for absorption to take place. Now, chemicals that are being released into the small intestine include amylase and lactase. There's also what's called pancreatic juice, which contains trypsin and bicarbonate ions. And there are three portions of the small intestine, so I would just recognize the order. There's the duodenum, the jejunum, and the ileum. Now, moving on to the large intestine, which is also sometimes known as the colon. The colon begins with the cecum, which is involved in the immune system because it houses probiotics, and probiotics are just good, helpful bacteria. The last portion of the large intestine is the rectum, and this is where feces storage occurs, and the external opening at the end of the rectum is the anus. Alright, so we've now covered the general digestive system, and we're going to get into the accessory digestive organs. Just a quick overview of these organs. We have the liver, which is the site of detoxification of blood and bile production. We also have the gallbladder, which is where bile is stored, and the pancreas, which releases a suite of digestive enzymes. Alright, so we're going to delve a little deeper into the liver with regards to its functions, one of which being the detoxification of blood by rendering toxins water soluble so it can be expelled from the body. Toxins generally are lipid soluble, so it needs to oxidize those toxins and conjugate them to become water soluble. Now I do want to note that this process for the liver is very important. Say you drink alcohol and a lot of it one night, you don't get alcohol poisoning because the liver is detoxifying your blood, unless of course you drink a lot of it. Obviously there are exceptions. Now this brings me to another important point, one that you should note, for instance, if you're going into med school or you might be a party person. Anything that is taken orally is going to pass through the liver, be it medication or alcohol. Anything that's taken rectally bypasses the liver. So say you're given medication that you have to take rectally rather than orally. There might be a reason that you need to take it rectally because you want it to bypass the liver. You don't want alcohol to bypass the liver. So those challenges that some people like to do by drinking through their anus is not a good idea for this reason alone, because if you do, the toxins never get to the liver to be detoxified and turned water soluble. Now, the liver also produces bile, which is important in the digestion of adipose tissue. It also produces cholesterol, which is very important because cholesterol is the precursor to many steroid hormones. And it also is involved in the conversion of glucose into glycogen for energy storage. Alright, so moving on to the gallbladder. The gallbladder is important, and it's always attached to the liver because it stores the bile that the liver has produced. And then it releases the bile through the common bile duct. Now, we've been talking about bile a lot, so let's go over its function. Bile is an emulsifier, and emulsification is just the breakdown of fat cells to increase the surface area for enzymes to interact with. That is just the function of bile. Alright, moving on to the pancreas. Now the pancreas is very important because it has both an exocrine and endocrine function. The exocrine function involves the release of digestive enzymes like trypsin and amylase into the small intestine. It releases these juices through the pancreatic duct, and these enzymes are secreted by the acinar cells. Now the endocrine function is the release of insulin to lower blood sugar and the release of glucagon to raise blood sugar. And these hormones are released from the islets of Langerhans cells. Now, the spleen is also considered an accessory digestive organ. This is where the breakdown, production, and storage of white and red blood cells as well as platelets takes place. The spleen also helps in filtering blood. So now that we've looked at the entirety of the digestive system, including the functions of all the organs of the GI tract, let's take a look at the digestion of macromolecules. So carbohydrate digestion begins in the mouth with salivary amylase, which is an enzyme that turns starch into glucose. Protein digestion begins in the stomach with proteases that turn protein to amino acids. Carbohydrates are not digested in the stomach. Lipid digestion begins in the small intestine via lipase and of course bile, because remember bile is an emulsifier. And then carbohydrates and proteins are also continually digested in the intestine. So that is it for the digestive system. I really hope this helps you. If you would like to test your digestive system knowledge, I have made a quiz video whose link should be at the end of this video for you to just press and it'll take you right there. I hope to see you next time. Thanks.